will see what are special cases. There are basically three special cases in truss. We will see one by one what are special cases. Now, this is a case 1 wherein you can see that there are three members acting at one joint. This is, say, any joint A. Now, from this joint, I have three forces F1, F2 and F3 going in the outward direction. So now what happens is, if I'm having two forces in linear direction, that is, the angle between those two forces is 180 degree, the force in the third member, that is in this case force F2, that force becomes zero force member. So in case 1, F2 is zero force member. Okay, now we will see case 2. Now, in this case, we can see that on a single joint, I'm having four forces, and the four forces are such that it is pairing two pairs like force F1 and F3. They are linear, collinear. So what I can say that the angle between these two forces is 180 degrees. Similarly, angle between force F2 and F4 is 180 degrees. Now what happens in this case? The force in F1 is same as the force in F3. So I will just denote it like this. I'll say that F1 is equal to F3. Similarly, the force in member F2 and F4 will be same. Okay, so we are done with two cases. Now we will see what is the third case. That is case 3. Now what happens in case 3? If I have a force member like this on a joint which is freely hanging, there is no support on this joint, or there are no external forces acting on this joint. So what happens in this case? In this case, the force in each member over here, F1 and F2, becomes 0. So F1 equal to F2 is 0. So we can say that without calculation, the force in member F1 and F2 is 0. So these are the special cases which we can use while solving any kind of a truss. If we get any kind of a special case in the truss, we can use this special case and then solve it. I just repeat that. Now case 1, if I'm having two forces F1 and F3 and they are collinear, so the force in member F2 becomes 0. If I have four forces acting at a joint and it is pairing like collinear forces F1 and F3, F2 and F4, so the force in member F1 will be same as force in member F3 and force in member F2 will be same as force in member F4. Case 3. At this joint, I don't have any external force, okay, or there is no support also. So in that case, these members become zero force members. Now we will see one example wherein we can at least get any of this case and how to solve that type of a truss. Okay friends, now you can see that in this truss, we have to find forces in all the members. That is, force in member AB, BC, CE, DE and AD. So how do we go about this? We have seen that the first step that we have to do in solving a truss is we have to find the stability criteria. So we will move ahead with finding the stability criteria of the truss. Now, once we get the stability criteria, that means if the truss is perfectly stable, then only we can go ahead in solving that kind of a truss. Just in case it happens that if the truss is imperfect, we are supposed to stop there itself. Now we can see that in this case, the the number of members that I'm having is 7, and my right hand side equation, that is 2j minus r, comes out to be 7. So I can say that left hand side is equal to right hand side. Since this is the case wherein my left hand side and right hand side are same, I can say that this is a perfect truss. Now, the next step that we have to do, we have to find out the support reactions. The support reactions, what we have to do in this case? The support reactions, for example, at this support, that is A, being a hinge support, I'll have one vertical reaction and a horizontal reaction. At support E, which is a roller support, I'll have only one reaction, which is perpendicular to the surface. Okay, students, now we can see that this is the next example wherein we are going to see how to use special cases. Now, in this truss, the first thing that we have to do is we have to find the stability criteria. Now we can see that in this case, the right hand side is equal to my left hand side. So we can say that this is a perfect truss. Now, after doing this, the next step that we have to do is find the support reactions. So students, you can see that in this case, when I have applied the condition of equilibrium for Fx, the equation becomes like I have one horizontal reaction over here. When I resolve these three forces, 4 kilonewton force, 2 kilonewton force and this 2 kilonewton force, the angle that is given to me is 60 degrees. So when I resolve these three forces, the reaction that I'm getting for the horizontal force comes out to be 4 kilonewton. Now, when I'm writing the equation for the moment, that is moment about A, what happens is this force happens to pass through the moment center. So the moment of this force comes out to be 0. this force, the 4 kilonewton force, this force is perpendicular. You can see that I'm having the perpendicular distance over here. So when I take the moment of this 4 kilonewton force, it becomes 4 into this distance, that is A, and that is clockwise. So I can write it as minus 4 into 8. Similarly, the force 2 kilonewton is having a distance of 16 meters. Now, when you see the force of the reaction, that is VE, that creates an anti-clockwise moment. So for that, what we need to do is we need to find out the distance between A and E. To do that, we can use the trigonometric ratios. The distance that I'm getting for the between the points A and E comes out to be 18.475 meters. So when I use this distance to find out the moment of VE, we get the equation to be as now. What we can do is we can find out the force in the reaction, that is E. It comes out to be and this is in the upward direction. Now when I substitute this value in this equation, I'll get the same answer, 3.465 kilonewtons in the upward direction. Now what we have done is we have calculated the support reactions. We have to move into the next step, that is using method of joints we have to find forces in all the members. Now coming back to the original figure. Now in this case, when I see joint A is having 4 forces. One is the horizontal force reaction, vertical force reaction, and the force in member AB and force in member AD. Now what happens in this case is these two are the unknown forces. I can find out these two forces by using the condition of equilibrium. We can see that the force in member is negative, so we can call it as a compressive force. Now, when I substitute this value of force AB in the equation of Fx, I'll get the force in member AD. Now we can see that we have already calculated the force in member AB and AD. Now, when I move on to the next joint, that is say joint B, what happens in this case? Again, I have two unknown forces, that is force in member BC and force in member BD. I have already calculated the force in member AB. So what I'll do is I'll draw the FBD of joint B. Now, we can see that in this force, that is force BD, we need to find out the angle, whereas the angle for force BC comes out to be 30 degrees. If I draw a horizontal line over here, the angle with the horizontal, the line BE makes is 30 degrees. So the angle that I'm getting over here is 30 degrees. Now what I need to do is, I need to find out the angle for force BD. Now students, we can see that what we have to do is, we have to find out the angle for the force BD. Now, if we look in this figure properly, what we can find out is the angle that we have seen for this BE line happens to be 30 degrees. So, by symmetric, we can say that the angle for this BD happens to be 60 degrees with the horizontal. Now, we can complete this equation for fx and fy. Now, in this equation, if I substitute the value of FAB, that is -4, I can get the two equations and then I can solve the two equations simultaneously to get the value of FBC and FBD. We can see that the force in member BC is coming out as negative, and that is a compressive force. Force in member BD is positive, so we can say that it is tensile force. Now, coming back to the original figure, we can see that we have already found the force in member BD and BC. Now what remains is the force in member CD, CE and DE. Now comes the special case part, wherein if I apply special case at joint C, we can see that at joint C, I'm having a force BC and CE which is collinear. Force CD and the 4 kilonewton external force are collinear. So by observation, I can say that the force in member CD is same as the external force, that is 4 kilonewton. By observation, again, I can say that the force in member BC is same as force in member CE. Now, we don't have to solve such type of a joint where we can know we can directly apply that special case. Now, we can see that this is a special case of type 2, wherein we have seen that the force in member F1 is same as force in member F3, and force in member F4 is same as force in member F2. So by observation, we can directly write the forces. Now, we have just shown the example of special case 2. What we need to do is we need to just write the forces now. The force in CD comes out to be compressive because the 4 kilonewton force is acting towards the joint C. So that is a compressive force. We have already calculated the force in member BC, and that comes out to be 3.46 kilonewton compressive. Hence, the force in member CE will be compressive. Now we can say that we have already calculated forces in member CD and CE as well. Now the only joint that remains is D or E, because I need to find out the force in member DE. So what I will do is I will take joint E. Now we have already calculated the force in member CE, and that was 3.46 kilonewton compressive force. Now what we have got over here is the force in member DE. Now that was the last member left out. That was the force in member DE. We have got the value of DE as well, and that is coming out to be 0.73 kilonewtons and a tensile nature for that. Now the last step that remains is to tabulate all the result that we have got. The values that we have got, these are the support reactions that we have got: HA, VA and VE. Now, FAB was 4 kilonewton compressive, FAD 2 kilonewton compressive. If I go for this joint, that was B, FBC, I have got to be 3.46 compressive, and force BD as 4 kilonewton tensile. Similarly, if I look for joint C, I have CD as 4 kilonewton compressive and CE again a compressive force of 3.46 kilonewtons. And the last step that we did was to find out the force in member DE, which was 0.73 kilonewtons tensile. So in this way, we have seen that how we have to use special case and solve any kind of truss that is given to us. If that truss is having a special case 1, we need to apply that case at that joint. In this example, what we have taken, it had the example of special case 2. So we used special case 2. In the next video, we will see that what is the special case for 3 or 1. That is the next example. Thank you.